Well, hello guys, and welcome to another video about Desmos and its nice practical features for graphing. Today we are going to discuss the properties of parabolas. Now, as you know very well, a parabola is nothing but the graph of a quadratic function. And so what we're gonna do is that we are going to check what a parabola should look like given that you have some of its properties well defined. Now, by definition, a parabola is a function where the highest exponent of the variable is 2. So here I have a nice parabola for you. When you have a parabola like this, ax squared plus bx plus c, we say that that parabola is in general form, and that parabola in general form, just for commodity's sake, I applied some parameters to it. Now you can see, of course, that these parameters might be changing. For example, I could just leave it without any linear component. See, there's a 0 there, and no constant term either. There's a 0 there. And if you do that, then the parabola is nice and centered like that. And then what happens if your a is bigger? Where predictably the parabola is thinner because it is elongated vertically. If your a is between 0 and 1, you get a fatter parabola because it is compressed vertically. For some value of a less than 0 but greater than -1, you get it reversed, what we call concave down. So this is concave down, this is concave up, and if a is less than -1, that's what you get. Now, I'm just gonna change this parameter from -2 to +2 to make it a little bit more manageable and see what it does very gradually. And let's leave it at 0.5. And now let's change b also. If b can go from -2 to +2, I want to see what happens as you vary the value of b. Now, it not only moves sideways, it also moves up and down. And that's a little difficult to predict. So we might want to look at another form of the parabola that we'll see shortly. But before we leave the general form, this is what happens when you have a change in the constant term. And that's very easy to predict. What is it really doing? It's simply moving up and down. It's easier to see if I just eliminate the linear term. See what happens when you have -2. The whole parabola moves down by 2 units, and now I'm moving it up by 2 units. So that's the parabola for you. And now we're going to make it go away by just pressing this little button, and we're gonna look at a more interesting form, the standard form of the parabola. Now here is a parabola in standard form, and I don't know where it came from, but I know it's algebraic form. This is a times x minus h squared plus k. That's the standard form of a parabola. And if you come over here and apply reasonable values to h and reasonable values to k, I want to see what happens. If you change the value of h to 0, lo and behold, your parabola is right on top of the y-axis, which means that its vertex has an x-coordinate of 0. If your k is 0, and so not surprisingly, that's exactly the same, because that's ax squared. What does changing h do? Well, it just translates the parabola horizontally. And so your value of h is your value of the x-coordinate of the vertex. Let's try and leave it at positive 1. Having a little trouble here. And now, what does changing k accomplish? Well, it just moves it vertically. So you can see now that if your parabola has an h of 1 and a k of 2, then your vertex is exactly 1, 2. After that, you are perfectly free to change the value of a and see what happens with this parabola. It just changed the concavity. So those are the parameters that you might want to play with whenever studying a parabola, and I hope you have a little fun with this, and thank you for listening. Bye bye.